In section 4.4, we're going to look at one of the most commonly used applications for exponential functions, and that is finding interest on a bank account. So suppose we have $1,000 in an account. After 1 year, what is the difference between a bank account that pays 12% interest once per year, we would say that's compounded annually, versus an account that pays 1% interest every month? We would call that compounded monthly. So if it just pays the 12% once a year, we have our $1,000, and that'll be times 1.12. So you can think of this 12% as our R, and our B is 1 plus R. So I added 1 plus that 12%, which gives you the 1.12. And we multiply that out, we get that your account now has $1,120. So you made $120 on that account. For part B, we're going to add interest each month. So we start with $1,000, and our R is this 1%, so B is 1.01. So the first month, we multiply by 1.01. And then that's going to add a little bit of money to our account. The following month, we're going to multiply by the 1.01. So we get interest on the $1,000 plus interest on this interest that we got the first month. This is going to continue for all 12 months. So each month, we're going to add another 1% on what's currently in the account. And that's going to give us a total in our account at the end of the year, $1,126.83. So we made about $6 more, almost $7 more on this account than we did on this one. That difference is that we're getting interest on the interest already. So this second month here, I'm taking 1% of the 1,000 plus that 1%. Right? So, and that interest on the interest adds up over time. It gives us just a little bit more money in that account. So our nominal rate here, that's kind of on the surface what it just looks like we're going to get is definitely that 12% here. And here, if we think about this really simplistically, like, oh, I get 1% per month, there's 12 months in a year, so that should be about 12%. Okay. Versus what the effective annual rate is. So that effective annual rate is how much interest you've actually earned. So in this case, we have this 1.01 to the 12th, right? Because we multiplied this out 12 times. And then we're going to subtract 1 off because that 1 is that initial $1,000 starting here. And that gives me an interest rate of about 12.683%. Okay, versus this one, because it's just on this one time a year, my effective rate is the same as my nominal rate. So this explains why we got a little bit more money on this account. So let's go ahead and define these terms as nominal and the effective annual rate. So as I said, that nominal rate is kind of, you can think of that as a rudimentary rate. It's just kind of a surface like, oh, 1% per month is 12%, more or less, okay? What it doesn't do is it does not account for the compounding. Okay, so we said that this one was compounded monthly, and this nominal rate does not take into account the compounding. Okay, and nominal means, we were going to just translate this as in name only. All right, whereas the effective rate is how much interest you earn in a year. And that's how much you actually earn. And that does include the compounding. And in the United States, this is often referred to, if you're looking at accounts, this is referred to often as the APY, the annual percentage yield. And we have a formula for finding that, and it's going to be very similar to kind of what we did here. So you'll take your nominal rate. So let's say they're telling you you're going to get 4% per month. So that 4% goes here. You want to make sure you convert that to a decimal. Divide by the number of times per year. Okay, and that's what that N is. You add 1 to that, raise it to the nth power, and subtract 1, and that tells you how much interest you're actually going to get there. All right, when we come back in the next video, we're going to actually take a look at how to do this.